Hi everyone, this video is part 1 of our new outline known as model building. So let's get started. You might be wondering that what skills we will cover in this outline. So here are some of them. We will learn about basics of machine learning, or you can say model building. Then we will see decision trees and random forest, linear and logistic regression, and then we will see metrics evaluation. In the last, we have two more topics of k-nearest neighbors and support vector machine. So what is actually machine learning in R? Machine learning in the R programming language refers to the use of algorithms and statistical models to analyze data and make predictions or decisions based on that data. R provides a variety of packages and libraries for implementing machine learning techniques, including classification, regression, clustering, and dimensionality reduction. These techniques can be applied to a wide range of applications such as predictive modeling, data mining, and natural language processing. So let's see the applications of R in machine learning. R programming language has a wide range of applications in the field of machine learning. Some of the common areas where R is used for machine learning include predictive modeling, and that means build predictive models for various applications such as stock prediction, credit risk analysis, and sales forecasting. Next, we have data mining. R provides a range of tools for data mining, including data preprocessing, feature selection, and clustering. Next, we have NLP, or natural language processing. R has packages for text mining and NLP, such as the TM and NLP packages, which can be used for sentiment analysis, text classification, and topic modeling. Next, we have computer vision. R provides packages for computer vision, such as the EBI image package, which can be used for image segmentation, feature extraction, and image classification. Then we have recommender systems. R can be used to build recommender systems for a variety of applications, including product recommendations, movie recommendations, and music recommendations. Then we have time series analysis. So R also have packages for time series analysis. So what is actually model building in R? Model building in R programming language refers to the process of creating a mathematical representation of a system or process based on data in order to make predictions or classify data based on input features. R provides a variety of packages and libraries for building machine learning models, including generalized linear models, decision trees, random forests, support vector machines, and neural networks. The process of model building in R typically involves splitting the data into training and testing sets, fitting the model into the training data, evaluating its performance on the testing data, and fine-tuning the model if necessary. The goal of model building in R is to find the best model that fits the data and accurately predicts the outcome for new data. Now, you don't have to worry about these things because we will dive into each of this topic in the next videos. So let's see the difference between machine learning and model building to make things more clear. Machine learning and model building are not the same thing, but they are related. Machine learning refers to a broader field of study that encompasses various algorithms, techniques, and approaches for creating algorithms that can automatically improve the experience, i.e., they can learn from data. Model building, on the other hand, refers to the process of creating a mathematical representation of a system or process based on data. In machine learning, model building is a crucial step in which a model is constructed to make predictions or classify data based on the input features Now, these input features are just like variables or columns in your data set. So, one could say that model building is a part of machine learning, but not all of machine learning is model building. So, let's move forward. What are the steps for machine learning in R? The steps for building a machine learning model in R can be summarized as follows. First of all, you do the data preparation. This involves loading the data into R, cleaning and preprocessing the data, and transforming it into a format suitable for modeling. Then we have exploratory data analysis. This involves visualizing the data and understanding the relationships between the variables. Then we have feature engineering. This involves creating new features or transforming existing features to improve the model's performance. Next, we have splitting the data. This process is about dividing the data into the training and testing sets, with the training set used to fit the model and the testing set used to evaluate its performance. Then we have model selection. This involves choosing a suitable machine learning algorithm and hyperparameters based on the problem type and the data. Then we have model training. This involves fitting the model to the training data and adjusting the hyperparameters as needed. Next, we have model evaluation. This involves evaluating the model's performance on the testing data and comparing it to other models to determine the best performance model. In the last, we have model deployment. This involves integrating the best performing model into a real world application and deploying it for use. These steps may need to be repeated several times with different algorithms and hyperparameters until the best performing model is found. It's important to note that building a machine learning model is an iterative process that requires experimentation, evaluation, and refinement. So, today's lecture is based on decision trees. What are actually decision trees in R? Decision trees are a popular machine learning algorithm used for both classification and regression problems. They are tree-like structures that split the data into smaller subgroups based on the values of the input features. The splits are chosen such that they maximize the separation between the classes or minimize the variance in the target variable, depending on the problem type. Now the question is that how to build decision trees in R. In R, decision trees can be built using the Part package or the body package, among others. The process of building a decision tree in R typically involves specifying the type of problem, let's say classification or regression, then specifying the inputs and outputs, splitting the data into training and testing sets, training the decision tree model on the training data, and evaluating its performance on the testing data. Now, what are the advantages of using a decision tree model? The advantage of decision trees is that they are simple to understand and interpret and can handle both categorical and continuous variables. However, they can be prone to overfitting, particularly if the tree is grown too deep, and may require pruning or other methods to prevent overfitting. Overall, decision trees are a powerful and widely used tool in the field of machine learning and are a good starting point for many problems. Now it's time for some hands-on session. Let's move to our studio. Well, first of all, I will load the package. I will say install.packages, and then I will say body, Earty. All right, let's run it. Now this body package has a built-in function with the name of C-tree, and that function is used to create a decision tree with the help of this package. So you can see that the package has been downloaded. And now it's time to say library, then body. I will load this package in our studio. And after loading this package, I will say head, and I will read a built-in dataset with the name of reading skills. You can see that this dataset has 4 columns: native speaker, age, shoe size, and score. In the column of native speaker, there are 2 values, yes or no. Now you know that we are going to predict the value of this column that has 2 binary states. So this is actually the process of classification. So first of all, I will create a variable with the name of decision tree. And in this variable, I will say C tree. Now let's use this built-in function to create a decision tree. And I say predict native speaker columns value, as this is my dependent variable. And now here I will pass the independent variables that play a role in the training, or you can say in the prediction of dependent variable. And these independent variables will be age plus shoe size. And I will also include the column of score to make prediction. And here I will say data equals to, and I will pass the reading skills data set. And down here I will say plot, and I will say plot this decision tree. Let's run it. Now you can observe here that the visual representation is congested. So I will just adjust the size of this plot. All right. Now you can see it better. From this plot, you can understand, or you can say that if the score size is less than 43.3 and the shoe size is less than 26.9 and the age is less than 31.0, then it means that you're not a native speaker. Similarly, if the reading skill score is greater than 43.3 and the age is smaller than 9 and the age is this, then you're most likely to be a native speaker. Now let's adjust it. Alright, so you have seen so far how to use the body package to make a decision tree. Now let's move forward. Let's install a new package. I will say install.packages, and here I will say rbout. Alright, let's make a decision tree this time with the help of this package. Alright, the package has been downloaded. I will say library in rbout. Alright, the library has been loaded, and now it's time to use a dataset. Let's use this iris built-in dataset. You can see 5 columns here: sepal length, width, petal length, and width, and species. So this time what we are going to do is that we're going to predict the species column. Here let's create a model. I will say decision tree model, and in this model I use the function of rbout, and here I say that predict the species column and take the variable or column of sepal dot length and sepal dot width and pedal dot length and pedal dot width in order to predict species. And here I will pass a parameter of methods, and let's say I pass the method of ANOVA, and in the last I will pass data set data equals to iris. All right, let's run it. Now before plotting, let's say I want to appear my file in the form of a PNG format. Let's say PNG file equals to, and I give the name of decision trees species model, and the width equals to 650 and height equals to 650. And now I say plot and I say decision tree model, and I use the parameter of uniform equals to true, and then I say main equals to, which is going to be the title of plot, species using decision trees. All right. And after the plot, I use the text and I say tree model, and I say 6 equals to 0.8, and I say use dot n equals to true, and in the last I say print, and here it goes, decision model. Now let's run it. Now you can see the printed model of your decision tree here in the console. Now let's test it. It's time to test the decision tree model. I will create a data frame of, let's say, test data. I will say data dot frame, and first of all I will say sepal dot length equals to, let's give a supposed length of 4.1, and sepal dot width equals to 2.4, and then I say pedal dot length equals to 5.5, and in the last I say pedal dot width equals to 2.5, 1.5, and here I will say cat, and I will say predicted value, which will appear as the title, and here in the last I use the predict function, and inside the predict function I pass the decision tree model, and then I say that predict the value of the test data that I had just given. All right. Well, I'm going to make a little change here, which is about removing the method equals to ANOVA, because I'm doing a classification task right now as I'm predicting the class of the species column. All right, let's run it. Now you can see here that most likely, according to the given values, the species is definitely not, because the value is 0. If the value is close to 1, then it means that yes, it could be. Versicolor is 0.9, and that means that according to these given values, the species of the iris flower will be versicolor. So let's solve a regression problem where we have to predict a numerical value. So let's do it. I will load the empty cars dataset. All right. And from this dataset, I want to predict the MPG. So let's create a decision tree model. I will say decision tree model 2. And I will say our part. And first of all, I will pass the dependent variable that I want to predict, and then the variables that I want to use for the prediction, such as cylinders, displacement, and HP, and cubic. All right. And I pass the method equals to NOVA because this time I'm solving a regression problem, and data equals to empty cars, which is a built-in data, PNG, and file equals to decision tree for regression. And here I pass the width equals to 650 and height equals to 650. And then next I say plot, and I pass decision tree model 2. All right. And then I say uniform equals to true. And next I say main, which is my title, and I say prediction of MPG using decision trees. And next I say text, and inside the text I pass my decision tree model 2, and I say 6 equals to 0.6 and use dot n equals to true. And here I say dev dot off, and in the last I say print decision tree model 2. Let's run it, where you can see once again a decision tree has been created for the prediction of MPG based on the variables. Let's create a test data frame, and I say data.frame, and inside this data frame I pass the values such as cylinder equals to 7 and displacement equals to 270 and HP equals to 310 and cubic equals to 15.8. And then I say cat equals to predicted value, and here I say predict, and I pass the decision tree model 2, and the test data frame equals to ANOVA. You can see that the predicted MPG is 13.4 based on these values. Now let's move back to slides. So here's what we have learned today. What is machine learning? What is model building? Difference between machine learning and model building. And you have also learned about a new machine learning algorithm known as decision trees and how you can build them. So here is the link of the dataset, and here is the homework for you. Now good luck. See you next time.